Hi, I'm John Gibbons, and I'm going to be running through one of the most important gas laws that we need to understand when it comes to starting out on our career as divers. And that is Boyle's Law. Now, Boyle's Law talks about the relationship between pressure and volume. And what Boyle discovered is that when the pressure goes up, the volume will decrease. So if you can imagine that you are underwater and you take a bottle that's sealed underwater, as you take it down, it'll become crushed. At the same time, as you fill that bottle back up with air, underwater, if you take it back up to the surface, it will expand. So I'm going to talk about the relationship between pressure and volume and the pressure we experience when we go underwater. So Boyle said that pressure is inversely proportional to volume. So as the pressure goes up, the volume would go down. So in order to calculate something like that, we talk about the pressure when we start and the volume when we start, P1 and V1, and that is equal to P2 and V2. So how do we put this into practice when we're diving? So we're going to go underwater now. Here we are at the surface, and at the surface we experience 1 bar of pressure. That pressure is the weight of all the air that is, in the atmosphere above us, and the weight of that, when it gets down to the surface, is approximately 1 bar in pressure. When we go underwater, and if we were to go down to 10 meters underwater, the pressure would increase by an additional 1 bar. So here we are at 10 meters. So now what we have is we have the combined pressure, combined pressure of 1 bar of the atmosphere and 1 bar of the water. So our pressure is now 2 bar. We're going to go down another 10 meters. We're going to go to 20 meters now. Another 10 meters of water. Each 10 meters of water will exert another 1 bar of pressure. Here we are at 20 meters, and so we'll have an additional 1 bar of pressure. So now, when we're looking at that, we have 1 bar from the surface, 1 bar from the first 10 meters, 1 bar from the second, and so we have 3 bar in total. And finally, we're going to go down another 10 meters. We're going to go down to 30 meters, and we're now going to have an additional 1 bar of pressure. So total, 1 bar from the surface, another bar, 1 bar, 1 bar, so a total of 4 bar of pressure that we now have as we've gone underwater. So as we go deeper, the pressure increases. Now how does this affect us according to Boyle's Law? So if we were to take a bucket at the surface, and this bucket has 4 liters of air in it. As we go down underwater, the pressure is increasing. So that same bucket now, the water inside, the air inside it would be compressed, and we now only have 2 liters of air in it. So while we had 1 bar of pressure, we double the pressure, we're now halving the volume. If we go take that same bucket down, and we're now going to take that same bucket down to 20 meters, we're now only going to have a third. So the pressure is tripled, so the volume will now be a third of that. So instead of having 4, all right, we'll have 1/3 of that, which is approximately 1.3. And now when we take it down to the next level, we're going to take it down all the way down to 30 meters. We're going to take it down to 30 meters. Hold on, pen. Take it down to 30 meters. Pressure is times 4, so now we're going to only have 1 liter of air in that bucket. Is all as the pressure's gone up, the volume is decreased. That's great. Now, what we're going to do is we're going to do exactly the opposite. We're going to have a balloon, and we're going to fill this balloon up. We're going to fill this balloon up at the bottom with 1 liter of air. Now, as this balloon goes up to the surface, the pressure is going to go from 4 bar, I'm going to take it up here, to 10 meters. The pressure has gone from 4 to 2, the pressure is halved, and what Boyle's law says is when you halve the pressure, the volume will increase. And now we're going to take that balloon up 1 more. We're going to take the balloon all the way up to the surface. And we would have 4 liters because the pressure has gone from 2 bar now to 1 bar. Pressure is halved, the volume's doubled, but unfortunately our poor balloon couldn't handle the pressure and it burst. Why is this important to us as divers? If we were to hold our breath when we were underwater, we'd take a full lungful of air from our cylinder and hold it and then go up to the surface. That air would expand out and cause damage to our lungs. Additionally, if we're a breath hold diver, right here, and we're taking a breath of air at the surface and we're going underwater, this causes all the air spaces in our body to be squeezed. Our lungs, our sinuses, our ears. You may have experienced this sometimes when you're underwater and you go to the bottom of a swimming pool and you're swimming along and you get a little pain in your ear. That's the pressure affecting you. So now, in the next lecture that we're going to do, we'll talk more about the air spaces in the body and how they're affected by pressure and why it's important to us as diving. Thank you very much. My name is John Gibbons. Thank you for listening.